In this video, I am going to talk about the isoelectric point. Before going to that, we want to know the basic structure of an amino acid. This is the basic structure of an amino acid. Here, you can see a tetravalent carbon at the center and to which 4 different groups are attached. One carboxyl group, one amino group, one R group, one H group. Here the R group is also known as alkyl group, or it is the side chain. So to the tetravalent carbon 4 different groups are attached. One is NH2 group, one COOH group, one H group and one R group alkyl group. When we dissolve this amino acid in an aqueous solution, we get a structure like this, because the proton of this carboxyl group, the hydrogen of this carboxyl group is transferred to the NH2 group. So the NH2 group becomes NH3 plus and the COOH becomes COO minus. And in this structure you can see one positive charge and one negative charge. So both charges are there in the same molecule. So this structure is known as citterion. And both charges are present in this, that is, both poles are present in the same molecule. So it is also known as dipolar ion. Similarly, both charges are present in the same molecule, so it is a neutral molecule. So this molecule is known as citterion or dipolar ion, or it is a neutral molecule. So when we are dissolving this amino acid in the aqueous solution, we get the citterion. It is also known as dipolar ion or neutral molecule. Now consider two conditions. Now let us see what happens to this citterion in that conditions. One is acidic condition and the another is basic condition. Acidic condition and the second one is basic condition. Now let us see what happens to this citterion in these two conditions. First one is the acidic condition. In the acidic condition, here the H plus concentration is more. In the acidic condition or in acidic solution, the H plus concentration is more. So the H plus is bind to this carboxyl group of the citterion. The H plus is bind to the carboxyl group of the citterion. So this COO minus will become COOH. That is, it becomes positive. These molecules become positive. The overall charge of this molecule will be positive. So it becomes a cation. So when we are doing the electrophoresis, this cation moves to the cathode. Electrode. When we are doing the electrophoresis, this cation moves to the cathode electrode, negatively charged cathode electrode. Similarly, consider the other condition, that is basic condition. In the basic condition, the OH concentration will be more. So what happens is, the H plus from the NH3, is moves out. The H plus from the NH3 moves out and forming water molecule. releasing water molecule, and it will be converted to NH2. So in the acidic condition, the OH concentration will be more, so the NH3, from the NH3 plus of the sutrione, the H plus will be moves out and forming water, and it is converted to NH2. So it becomes, this molecule becomes negatively charged. The total charge of this molecule will be negative. So it becomes an anion. So when we are doing the electrophoresis, this anion moves to the anode electrode. When we are doing the electrophoresis, this anion moves to the anode electrode. Anode electrode, positively charged anode electrode. Here you can see pK1 and pK2. These pK1 and pK2 are dissociation constants. pK1 and pK2 are the dissociation constants. These are all the things that I had explained in the previous video. Now coming to the isoelectric point. What is isoelectric point? At a particular point, this sutrione does not move to the cathode or to the anode. The sutrione does not move to any of the electrode. That particular point is known as isoelectric point. Isoelectric point. So the point at which the sutrione does not move to the anode or to the cathode, that particular point is known as isoelectric point. This is because of the presence of the neutral charge in the sutrione. You can see the sutrione contain both positive and negative charge. So it is a neutral molecule. So this cannot move to either of the electrode, or either to the cathode or to the anode. So isoelectric point is the pH at which the compound has equal number of positive and negative charges. That is, the compound is electrically neutral. So the isoelectric point is the pH at which the compound has equal number of positive and negative charges. Now let us calculate the isoelectric point, or Pi. For the calculation of isoelectric point, you want two different pK values, dissociation constant values. So it is calculated by dividing the sum of their different pK values. That is, Pi equals pK1 plus pK2 by 2. Here you can see two pK values, pK1 and pK2. We can use both these values to calculate the Pi. Pi equals pK1 plus pK2 divided by 2, or Pi equals half of pK1 plus pK2. So the average of the pK1 and pK2 is the isoelectric point. Here pK1 and pK2 are the dissociation constant of acids. Now let us see one example using glycine. What is glycine? Glycine is an amino acid in which the R group is H. Instead of R, we can use H. NH2 COOH. So this is the structure of glycine. In the case of glycine, the pK1 is 3.24. Sorry, 2.34. 2.34. pK1 is 2.34. And pK2 is 9.6, approximately 9.6. Then how can we calculate the Pi? Pi equals 2.34 plus 9.6 divided by 2. That is equal to 5.97. So in the case of glycine, the pK1 is 2.34 and pK2 is 9.6. Then by using this we can calculate the Pi. Pi equal to 2.34 plus 9.6 by 2, that is approximately 5.97. So the Pi of glycine is 5.97. So at this pH or at this Pi value, the glycine molecule will not move either to the cathode or to the anode. This particular point is known as isoelectric point. So isoelectric point is a particular point at which the zwitterion molecule will not move either to the cathode or to the anode. This is about the isoelectric point. Thank you.